Hello my dear students, this video is related to strategy for designing algorithms of Unit 1 PSP. Strategy for designing algorithms. Strategy for designing algorithms. Some of the important characteristics to design an algorithms are: first one is investigation step. Some of the important characteristics to design an algorithm are: first one is investigation step, the second one is development step, second one is development step, and third one is stepwise refinement. Some of the important characteristics to design an algorithm are: first one investigation, next one is development, third one is stepwise refinement. In this investigation step, here the user is going to be identify all the input variables, and that means through this algorithm it is going to be identify all the input variables. So here in this identification step, which is meant for identification of input variables, after that, after identifying the input variables, identify the output needed. What is the first specification? Identification of input variables. After identification of input variables, then identify the output, whatever the output is needed. And third one is identify major decisions and conditions. What are the conditions where it has to be execute, where it has to be terminate, the major decisions and conditions. And last one is identify the process required to transform inputs into required outputs. So identify the process. So where the input is going to be transformed, input is going to be changed. And for example, if we given the two variables for addition of two numbers like a and b, so after making addition process, that is comes result as a plus b. The result as a plus b. And the second step in this strategy for designing algorithms is development step. What is the first step? Investigation step. What is the second step? Development step. In this development step, it divides overall problem by identifying the major components of the system. So here, in this development step, here it is going to devise overall problem. It is going to be understood the overall problem by identifying the major system. What are the major components of the system? So you are going to develop the algorithm by based on the major components and what is the main criteria, and verify the feasibility of breaking up the overall problem solution. Again, so the problem may have the several steps. All these several statements can be grouped together to form as a one kind of component. So here you need to break up the different kinds of statements in different levels. So verify the feasibility. So where you need to break up all the statements. And third one is stepwise refinement. This stepwise refinement process is going to be work out every detail of each small piece of manageable parts. So it is going to be work out every detail of each small piece of manageable parts. So here it is going to be work out every detail of each and every specification of the small piece of manageable part, and it is going to be look each and every statement. Next, if you decompose any solution procedure into smaller pieces, if it is having any specification which is required, it is going to be decomposed into the smaller pieces. Next, group process together which have same commonality. So it is going to be group process all the similar processes together which have same commonality. Next, test each small procedure for its detail and correctness. So it needs to be test each and every procedure for correctness. So this is the strategy for designing algorithms. So what are the some important characteristics to design algorithm? First one is investigation, next one is develop, third one is the stepwise refinement. And the next question is tracing an algorithm to depict logic. Tracing an algorithm to depict logic. So what is an algorithm? Algorithm is a step-by-step procedure to solve the given problem statement. Already we know that algorithm is a step-by-step procedure to solve the given problem statement. So that means here it includes different procedures which is arranged one after other are to be executed in the given order. So in algorithm it is going to be made to execute the different procedures which are arranged one after another to be executed in given order or skipped or implemented repeatedly based on the constraints, based on the some conditions. So it is going to execute all the statements sequence by sequence, step by step. Sometimes it is going to be skip some statements. Why it needs to be skipped? Based on the condition, based on the condition. So for tracing an algorithm, it involves verifying the outcome of each and every procedure. It is going to be verify the outcome of every procedure in the order they are placed, and confirm the corresponding results that is to be obtained. So here the tracing is going to be involved the verifying the outcome of each and every procedure. So how it can be? For example, let us take this small example, that is the biggest of three numbers algorithm. It is biggest of three numbers algorithm. As usual, step 1 start input. Here we are going to be three variables x, y, z as a three values. So here what is this step? This step is known as investigation step. In investigation, what you are doing? First, you need to be identify the input variables. So here we identified input variables as x, y, next one is the z. So in step 3, you are going to make some condition. You are going to check some condition. So here, which is going to be checked the condition, which is also known as the investigation step. If x greater than y and x greater than z, then automatically what is the biggest value here? If x greater than y, x is the maximum. If x greater than z, then also x is the maximum. So the maximum value is the x. If it is x is not the maximum, then again it is going to be checked. Again, if y greater than z, then automatically the maximum value is y. If it is not satisfying these two conditions, next, which is bigger? Z is bigger, Z is max. This is the algorithm, simple algorithm for finding out the biggest of three numbers. So how it is going to be traced out? So this tracing process is in the form of first case 1. Assume the values for x equal to 7, y equal to 5, z equal to 3. So you taken three values for x 7, y equal to 5, z equal to 3. So what is our first condition? Our first condition is x greater than y and x greater than z. So what is the x value? X value is 7, y value is 5, z equal to 3. So 7 is greater than 5 and 7 is greater than or equal to 3. If it is true, then automatically which is the bigger? 7 is the bigger, hence maximum value is 7. Maximum value is 7. Or else, then we go for the other statements. So here case 2, assume x equal to 5, y equal to 17 and z equal to 3. The another example, this. Here we are going to trace out. In first example, we taken the values are x equal to 7, y equal to 5, z equal to 3. But in this example, there x value is the maximum. But here, which value is maximum? Y value is maximum. So here, how it can be executed? So first, 5 greater than 17 and 5 greater than 3. So here, which is it true? So which is not true condition. Which is a what kind of condition? False condition. Then again, covered here, false and true is known as false. Again, it is going to be checked the other value, that is 17 greater than 3. So 17 greater than, that means 17 is nothing but what? Y. Y greater than Z. Yes, it is true. It is true means the maximum value is 17. So that is the second case. And here we taken the Y value as a maximum value. In first case, we taken X value as a maximum value. So the tracing process in this way. Similarly, in case 3, assume X as a 7, Y equal to 5, Z equal to 13. So here, which value is maximum value? Z value is the maximum value. So let us again, you trace it. That means simply substitute the values. 7 greater than 5, 7 greater than 13. So here, which is false. So that means this one is true, this one is false, this one is true, this one is false. True and false are false. Again, 5 greater than 13 false. Again, hence automatically the maximum value is this one. So in this way, here all tests are completed and expected outputs are achieved. That means tracing process completed. So in this way, you need to simply substitute the values into algorithm. That is. So all test cases are successfully completed. That is. So the next one is specifications for converting algorithms into programs. So algorithm is what? The algorithm is a step-by-step procedure. That means the algorithm steps are converted into programs using some programming language. Each algorithm step is converted into specific instruction of the programming language. So each algorithm step is going to be converted into the specific instruction of the programming language. That means it is going to provide some solution to the problem statement. So the general procedure to convert an algorithm into program is given as, one is code the algorithm into program. Code the algorithm into program. So what is the first specification is in the sense for converting the entire algorithm into programming language. So first what you have to make some code generation for the algorithm. So that will be converted as a program. That means for converting the algorithm into program through code, first what you have to do, you need to understand the syntax of the selected language. For converting algorithm statement into programming language, first you need to understand the syntax of the selected programming language and convert algorithm steps into equivalent instructions. That is, so you need to generate the program code according to the syntax. For that one, you need to understand the syntax. Next one is check the program. Check the program. So here you need to check the program code and make sure that the sample data produces the expected output. So you need to be checked whether which is going to execute the output or not. And third one is evaluate and modify if necessary the program. Evaluate and modify if necessary the program. So based on the output of the program, make program code changes. Based on the output of the program, you can make modifications to the program code, and if necessary, make changes in the original algorithm also. Sometimes our algorithm logic may be somewhat different, so you need to be change the algorithm also based on the programming language. That is, and last step is do not reinvent the wheel. So that means if the design code already existed, you make use of that one. Why? Because software is reusable one. So you modify it, but do not remake it. And don't go for the new development. You can make use of the old program already pre-developed one. That is. So these are the different kinds of converting procedures to convert the algorithm into program. So let us take example. Consider the algorithm for addition of given two values. Start, input xy, sum x plus y, print sum, stop. So in order to convert this algorithm into procedure, then you need to be convert into the C program in this way. Later I will explain this program in detail. Don't worry about this. So it is the equivalent. So For this algorithm, we generated the code in C language. So there we take a three variables x, y, and another one is sum. So this x and y for input, sum is meant for storing the result, that is the output. So there is the specification. Later I will explain in detail. Don't worry. For any doubts, contact through my mail ID iswarvta@gmail.com and my phone number. And this is, you can contact me through WhatsApp. I will clarify your doubts. Thank you.